Welcome back to Old School Math. Today we're going to take a look at inverses of functions. Now, first thing I want to do before we start looking at inverses is look at two graphs. I've got a graph here of a quadratic y equals x squared and a square root y equals square root of x. What similarities and differences do you notice between these two graphs? You might say they have a similar curvature, right? We can see this side of the x squared graph looks pretty similar to the curve here of the square root graph. You also might say some things like, well, as far as differences, this one's going up and this one's going kind of more out than up. This one is a U shape and this one looks like maybe it's just half of the U shape. So there are some similarities and differences in how they curve in the overall shape of the graph. If two functions are inverses, then they will reflect over the line y equals x. Now I'm going to zoom in. I'm going to zoom in on this graph. And we're going to take a little bit of a closer look here at the part that we can really see the curve in, right? So we can really see the curves here in this first little part of this graph. And I'm going to make sure that I've done a zoom square just so everything lines up nicely. Okay? So now the third graph I'm going to make is y equals x. Now, as this black line gets graphed through here, we see that both parts, at least in quadrant 1, look to be perfectly reflected over this line. Each point looks like it's the exact same distance away from the black line y equals x. So this would indicate that at least part of these two functions are inverses of one another. Now, if you want to find an inverse algebraically, it's actually a pretty straightforward process. First thing you're going to want to do is rewrite the equation, but replace the x with y and the y with x. So you're just going to switch the x and y, and then you're going to solve for y. Now, this is the new function, the new function here that we've created is the inverse function. So we want to be sure to write it with the appropriate notation. And the way that we're going to indicate that is instead of saying f of x for our original function, we're going to call that f inverse x for the inverse function, okay? So let's see how this works with a couple examples. So here we're finding the inverse of f of x equals negative 2x plus 5. Now we don't have a y here to replace, but we can go ahead and set it, instead of having f of x, we can just write that as y. Next thing we're going to do is rewrite it, x equals negative 2y plus 5. Now here's where your solving equations actually comes in pretty helpful. We're going to need to subtract 5 on both sides. So we get x minus 5 equals negative 2y. And it's tempting at this point to add 2 to both sides because we've got a negative 2. But keep in mind that 2 is multiplied with y, so we're going to need to divide by negative 2. So we get y is equal to x minus 5 over negative 2. Now this looks kind of funny, but I think it's an okay way to write the function. You can still put that in your graphing calculator and graph it. The last thing we want to do right here is say write it with the appropriate notation. So instead of saying y, we're going to call that f inverse of x. And that exponent of negative 1 always indicates the inverse. Okay? In example 2, we've got the f of x equals x cubed minus 4. Again, we're going to rewrite this. Instead of f of x, we're going to write that as y. And then to find the inverse, we want to switch x and y. X equals y cubed minus 4. So from here, we're going to add 4 to both sides. So we get x plus 4 equals y cubed. Now to undo this y cubed, we want to take a cube root. So here we've got the cube root, or y, let's write this over here, equals the cube root of x plus 4. And again, this isn't the really best way to write this because this would be something we could graph, but it's not necessarily the inverse of the function. So let's write that as f inverse of x equals the cube root of x plus 4. And we're done. If we were to graph these two functions, and let's do that together, we would see that they reflect over the line y equals x. So I'm going to leave this y through as y equals x. We'll graph y1 as x cubed. Let's just start over. X cubed minus 4. And then in this one, we are going to graph the cube root, which we go to math and down to option 4, the cube root of x plus 4. And that x plus 4 is all in the cube root. So here's my x cubed. Here's my cube root. And finally, we got the line y equals x. Okay? And so we can see how this is a perfect reflection over this line here. If I zoom out to a standard window, it might not look perfect, but that's because the scaling you can see here of the y-axis is a little bit different than the scaling of the x-axis. The x-axis looks to be stretched out a little bit. So one way to get around that is hit zoom and then go down to option 5, and that'll be zoom squared so that the spacing on each axis is the exact same. And we should see here now that these do make a nice reflection there. Now keep in mind that this goes out a little bit farther maybe than the y-axis. The y-axis only goes up to about 10. I think this comes out to maybe 14 or 15. But if we look at this here in this window, we see a nice little reflection there across that axis. All right, so far everything's working. The graphs look good. Let's do another one. Instead of f of x, we're going to rewrite that as y. Y equals negative x minus 3 plus 1. So if we think about our transformations, this is an upside down graph. It is moved to the right 3 units and up 1 unit. And that's the parent function of a square root. So let's rewrite this. X equals negative square root of y minus 3 plus 1. Now when we're solving something like this, where we've got some stuff going on in the square root, we know to undo a square root, we have to square it. But we can't square it until we have the square root by itself. So let's go through and get everything away from the square root. X minus 1 equals the negative square root of y minus 3. And then from here, to get rid of that negative 1, we can multiply this whole function by negative 1, which means we'll multiply this side as well by negative 1. So that would give us a negative x, and negative 1 times negative 1 is positive 1. So negative x plus 1 is equal to the square root of y minus 3. Now I'm running out of room, so I'm going to go up here and rewrite it. Okay, now that I have the square root all by itself, now I can square both sides. Okay, so I'm going to leave this negative x plus 1 squared all together, and that's going to equal, when I square a square root, that goes away, y minus 3. And then from here, I can add 3 to both sides. Negative x plus 1 squared plus 3 equals y. Last but not least, we want to write this instead of in terms of y, in terms of f inverse of x. So we just write f inverse of x equals all this stuff. And that would be the inverse. Last but not least, let's do this with the x plus 1 squared plus 2. Get rid of the f of x, let's call that y. And now let's rewrite it with y and x changed. So x equals, parenthesis, y plus 1 squared plus 2. And we'll do the same thing that we did in this one. We're going to get rid of all the stuff around the parentheses and then take care of the parentheses. So to undo a squared, we'll do a square root. So we'll subtract 2 on both sides. So get x minus 2 is equal to y plus 1 squared. And so now we can do a square root on both sides. So square root of x minus 2 is equal to y plus 1. So when we did the square root of this quantity squared, it got that to drop out and just left what was inside. Subtract 1 on both sides. We get y is equal to the square root of x minus 2 plus 1. And last but not least, we'll write this instead of in terms of y, in terms of f inverse of x. And that equals x minus 2, square root of x minus 2 plus 1. Guys, finding an inverse can be a tricky process if you're a little bit rusty or shaky with some of these problem-solving skills with solving an equation. But I'm going to say this, right? If you've got a square root and you need to undo the square root, square it. If you've got a cube root and you need to undo the cube root, cube it. If you've got a lot of other things that that are backwards. If you've got a quantity that's squared and you need to undo that, take a square root. If you've got a quantity that's cubed, take a cube root, and so on. So this should be a pretty easy process, or a pretty straightforward process, and there's only like 3 steps to it, right? Rewrite the equation, replacing the x with y and the y with x. Solve that new equation for y, and then write this with the appropriate notation, that is the f inverse of x. Thank you for watching this video.